In this video, we will look at measures of variation. There are several measures of variation in section 3.2 of your textbook, and we will look at each of them and do some examples. So the range is the first one, and it is the easiest to compute. You simply take the difference between the highest score and lowest score, the biggest number and smallest number in a data value. Standard deviation is the one that is used the most in statistical applications, and the idea of standard deviation is that it measures the spread, or how far apart data values are, by looking at deviations away from the mean. So we start with the mean and then look at how far away from the mean each individual data value deviates. Hence, it's sometimes referred to as a typical deviation from the mean. The variance is really just a function of the standard deviation. Once you have the standard deviation, if you square that number, you will have the variance. So a little bit of notation. We generally use R, capital R, for the range of a data set. S and S squared are our notations for sample standard deviation, sample variance. Now, when we refer to population parameters, we usually use Greek letters. So remember, with the mean, we used X bar for the sample mean and mu, or the Greek letter mu, for the population mean. Similar idea here with measures of variation. S and S squared are sample variation, sample standard deviation. Sigma or sigma squared are our population parameters in this particular case. So if we look at a set of data, so this is similar to the data set we had in the previous video. We have 12 numbers, so n is 12 here. So the range is simply the difference between the lowest and highest. The biggest number in this data set is 6.3. The smallest is 1.9, so the range is the difference between those two, or 4.4. Now, formulas for standard deviation are a little messy, and so to do these by hand is kind of a tedious calculation. So I encourage students to learn how to use the statistical functions on your calculators. Most calculators have basic statistics functions that will allow you to calculate the mean, the median, and the standard deviation or variance. If you have buttons on your calculator, X bar, Y bar, S, S squared, or sigma, sigma squared, you have statistical functions. There's a separate document in Blackboard that goes through some basic stat functions on various calculators. But the formulas look something like this. And so the first one is sometimes referred to as the definition, because notice it takes each individual value minus the mean and squares it. That's where we get those deviations away from the mean. Now the second formula is sometimes, referred to as the computational formula. It is the same formula. You'll get the same answer either way, but you calculate a little differently. So the first part of that formula, you have the sum of the x squareds. And what that means is first take each individual value and square them, then add them all up. The second part of that, notice the sum of the x is in parentheses, so you first add the numbers up and then square the result. And those are two different things if you think about it. Okay? So those are the formulas we would use. So in this example, if we plug all this in, we get 1.1069. And so I would encourage you again to learn how to use the stat functions on your calculator. Once you have the standard deviation, the variance is simply that number squared. So in this case, 1.1069 squared would give you the variance. Now I think it's important to understand what the standard deviation measures. So standard deviation measures how spread out numbers are. Okay, so numbers that are further apart are going to have a larger standard deviation. So if we have this example here, I have some numbers and I purposely put them in order. So I'm going to ask a couple of questions. First, let's talk about the middle of this data set. What would the mean be equal to? So not going to do any calculations here. Just estimate where the mean is. The mean is the average. Okay, so if I look at those numbers and how they're spread out, I would guess the average is somewhere in the 50s or 60s. Okay, it clearly cannot be 90. All the numbers are less than 90. It really couldn't be 30 because there's only one number below 30. So the average has to be somewhere in the middle. So I would guess around 55 in this case. And if you actually calculate it, add those 6 numbers up and divide by 6, you get 50.83. So now let's talk about standard deviation and think about what it measures. So standard deviation is a typical or average deviation away from the mean. So in this particular case, the mean is about 51, if I rounded to a whole number. So if I look at the individual data points and think about how far they deviate away from the mean. So like 5 would be about 46 units away from the mean. 32 is about 18, 19 units from the mean. 50 is about 1 or 2 units away from the mean. All the way up to 81 is about 30, 31 units away from the mean. So the standard deviation is sort of a typical or average of those deviations. So if I think about it, obviously it can't be 3. Those numbers are further apart than 3 units. 55 is really too much. The mean is at 51. No values are that far away from the mean. But 25 seems reasonable. I think about those deviations we had, 46, 18, 2, 12, etc. The average of those deviations is going to be something in the 20s. So if you actually calculate this, so here'd be another good one to practice plugging into your calculator. Plug those 6 numbers in, you get a standard deviation of 28.55. So a typical or average deviation away from the mean is about 28 or 29. Now, suppose I added one more number to this data set, put a 39 in there. What would that do to the standard deviation? So what I have to think about is, how does that affect the deviations away from the mean? So if I put a 39 in there, the previous mean was about 51. So if I put a 39 in there, that mean's going to go down a little bit. Maybe say it goes down to 49. Okay? Well, what's the standard deviation going to do? Now I'm looking at how far they deviate away from the new mean. Well, notice 39 is only 10 units away from that new mean, which is smaller than the previous standard deviation. So I've put in a value that's a little bit closer to the mean than the average has been. So this would decrease that standard deviation. Okay? So when you look at data sets and talk about standard deviation, it's a typical deviation away from the mean. So as you move numbers closer to the middle, closer to the center, the standard deviation would get smaller. As you move values away from the center or away from the mean, they get larger. Another common question I ask in an example like this is to change 2 numbers so that the mean stays the same, but the standard deviation gets bigger. So like in this one, I could take that 5 and that 81 and move each of those 5 units further from the mean. Make it a 0 and an 86. Notice I haven't changed the mean. The average would still be the same, but I've moved numbers further from the mean so that standard deviation would get larger. So standard deviation is the most common measure of variation that we'll use in statistics.